All right, so we're going to start chapter 1, section 4, part A. All right, so we're going to solve more equations. We're going to continue on that topic, but this time we're going to solve by factoring, and then later on in this video we're going to solve by taking the square root. All right, and we're continuing on the lesson of solving equations, right? So in chapter 1, section 2, we really only dealt with linear equations, and even though there were some rational equations, right? Once we eliminated the denominator, we were still left with not so interesting cases, right? We still had linear equations that you guys are able to solve, right? So we're going to get into some newer material, right? Maybe you've seen this in Algebra 1, right? But we're still going to continue on the topic of solving quadratic equations this time, right? And I'll get into more about what that is in a minute. All right, so to solve equations by factoring, we want to get all the terms to one side, setting the equation equal to 0. And then we want to factor the equation, and then we want to set each term or set of parentheses equal to 0, and then you solve from there, right? So we still need to solve basic linear equations, right? But in order to do that, we need to know how to factor, right? And like I keep telling you all in class, right, factoring is not going away. You're going to keep seeing it again and again. Right, so keep on practicing factoring if you're not yet comfortable with it, right, because it is not going anywhere, right? It's not a one-time thing, right? It's going to keep showing up, right? So today we're going to be factoring all kinds of things, right? So let's get started. All right, so just taking a glance at some of these problems, all right, do we notice anything about our variables? Right, take a minute to look at it. You should notice that they all have a 2 in the exponent, right? So you'll learn in a later section, the number in the highest exponent is going to be the number of solutions that you want, right? So in all of these, we should expect to see 2 solutions. All right, we want 2 solutions in all of these problems. All right, so let's start with the first one. All right, so first thing we want to do is get all the terms to one side, right? Setting it equal to 0, right? Is that done? Yeah, right? X squared minus 1 equals 0, right? As long as we have the equal 0, we're good to move on to the next step, which is factoring, right? So now we want to factor. We want to factor x squared minus 1. Now, how does this factor? Right? This is a super easy one, right? It's a difference of perfect squares. Right, you take the square root of the first, square root of the second should be x plus 1, x minus 1, right? And set it equal to 0. And now that it's fully factored, right, you set each factor equal to 0, right? So set each factor equal to 0, right? So we're going to do x plus 1 equals 0, x minus 1 equals 0, right? This is a factor, and this is also a factor, right? So then we do x plus 1 equals 0, x minus 1 equals 0. We have 2 equations here, right? So now solving each of them, x plus 1 equals 0, we want to subtract 1 from both sides. We get x equals negative 1, right? And x minus 1 equals 0, we want to add 1 on both sides, right? So we get x equals 0 plus 1 is just 1. So again, we should get 2 solutions, right? We do get 2 solutions here. All right, now you might be thinking, why are we setting it equal to 0? Why does this work? Now, this is true by something called the zero product property, right? Or ZPP, right? That's how I learned it. Right, zero product property. This just means, okay, well, if you set each of these factors equal to 0, all right, well, if you multiply anything by 0, you're going to get 0, right? So what does at least one of these need to be, right? Let's say x minus 1 is not 0, right? So then what does x plus 1 have to be for it to equal 0? It has to be 0, right? Because you need to multiply this by something to get 0. The same thing with x minus 1. Let's say this x plus 1 is not 0, right? But that means x minus 1 has to be 0, right? Because the only way that you can get 0 from multiplying two things is if one of them or both of them is equal to 0, right? So this is called the zero product property, right? So you set each factor equal to 0 because when you multiply 0 by anything, you get 0, all right? And this only works if you set it equal to 0, right? So let's say, just for example, let's say this was like 5 or something. Now you can't just say, oh, x plus 1 equals 5, x minus 1 equals 5, right? Set them both equal to 0. No, this is not correct, right? It only works for 0, right? Because 5 has a bunch of different factors, right? You don't know which one is which, right? But with 0, we're always certain that one of these has to be 0. All right, so that's why we use this method to solve by factoring. All right, now, if you didn't want to pay attention to any of that, perfectly fine, right? Because I'm going to show you some examples, right? This stuff is actually maybe is going to be more useful to you, right? But if you wanted to know why we're doing this, right, this is why, all right? So let's do the same thing with number 2. Right, group all of your terms to one side, setting it equal to 0, right? Is this step done for us? Yes, it is, right? So we can move on to the next step, which is factor, right? So let's factor 3x squared plus x, right? All we have to do here, there's only 2 terms. There's not many options that we can do, right? So we're going to take out an x. We're going to take out a GCF, and we're left with 3x plus 1, and then all of this still equals 0, all right? Now, is this fully factored? All right, yes, it is, right? So now what we want to do, right, is we're going to set each of these equal to 0, right? We're going to set each factor equal to 0. So we're going to set x equal to 0, and then 3x minus 1, or 3x plus 1 equal to 0, right? We want to set both of our factors equal to 0, right? Now, x equals 0, there's nothing we need to do there, right? This is already one of our solutions, right? As long as we have x by itself, x is allowed to equal 0, right? And now let's do 3x plus 1 equals 0, right? We just want to solve this for x. All we have to do, subtract 1 on both sides. Then we get 3x equals negative 1. Divide by 3, we get x equals negative 1/3. All right? So then we get x equals 0 and x equals negative 1/3. Right, and this checks out because, again, we're always supposed to have 2 solutions, right? The highest exponent is a 2, right? So we should see 2 solutions, all right? Now, again, just to reference what I mentioned in this first example, right? What we mean when we say that x equals negative 1/3 is a solution, that means when we plug it back in here, one of our factors is going to be 0, right? So again, 0 times anything is 0, right? So that's how we find the value for x, right? We're just doing this to look for a value for x, right? Good. And now let's try number 3, right? First thing we always want to do, get all of our terms to one side. Is this step done for us? No, it is not, right? So we want to get all of our x terms to one side, right? So I have x squared equals x. All right, I'm going to go ahead and bring that x over to the other side, right, by subtracting x. All right, and then so on the left, we have x squared minus x. And on the right, x minus x is 0, right? So this equals 0. So now we can solve it the same way that we did the others, right? Factor, right? X squared minus x, you can take out a GCF. All right, and then you're left with x times x minus 1 equals 0. And now by the zero product property, right, the ZPP, set each of these equal to 0. We get x equals 0, x minus 1 equals 0. X equals 0 is already a solution, right? There's nothing more you need to do to that. X is already by itself, right? So now all you have to do on this other side is to get the x by itself, you need to add 1 on both sides, right? Negative 1 plus 1 goes away. Then we get x equals 0 plus 1 is 1. All right. So if you're proficient in factoring, right, it should be very easy for you, right? Again, like I keep mentioning, factoring is not going away, so make sure you practice, practice, practice. All right, let's try the same thing for number 4. First, are all the terms on one side of the equation? Yes, they are, right? So now we want to factor, right? Let's factor this equation, x squared plus 2x minus 8. All right, this is one of our cases where our first term is 1, right? So we're looking for numbers that multiply to negative 8 and add to positive 2, right? So factors of negative 8 that add to positive 2 should be positive 4 and negative 2, right? 4 times negative 2 gets you negative 8, and when you add them together, you should get positive 2. All right, and now is this fully factored? Yes, it is, right? So now we use the zero product property, right, to set each of these factors equal to 0, right? X plus 4 equals 0, x minus 2 equals 0. All right, and then we want to just solve each of these for x, right? So subtract 4 on both sides, add 2 on both sides. All right, then the 4 minus 4 goes away. We get x equals negative 4. All right, and then we want to get rid of negative 2 plus 2. Then we get x equals 0 plus 2 is 2. Right, so we get 2 solutions. Again, we should always get 2 solutions when the highest exponent is 2, right? 2 solutions of x equals negative 4 and x equals 2. All right, now let's just keep going with some examples. All right, so number 5, all right? Now this isn't the super duper easy case where a equals 1 and you can just find factors of negative 15 that add to 1, right? No, this is our a times c case, right? We have to multiply the first term times the last term, right? So 2 times negative 15 is negative 30, right? So we're looking for 2 numbers that when we multiply, we get negative 30, and when we add them, we get negative 1, right? Keep in mind, this negative x is the same as negative 1x, right? So factors of negative 30 that add to negative 1 should be negative 6 and positive 5. All right, negative 6, positive 5. All right. Now, some of you maybe get to this step, right? Especially in these kinds of cases where our first term is not 1. And then you're tempted to say, okay, well, it's going to be x minus 6 and then x plus 5, right? No, right? This is not true, right? You have to actually break up the middle term, right? Don't forget this. Like I said, factoring is not going anywhere. We want to break up the middle term and then factor by grouping. All right. And then in each group, you want to take out a GCF. So in our first group, 2x squared minus 6x, we can take out, oh, don't forget the equals 0, right? We can take out a 2x, and then we're left with an x minus 3. And then in our second group, 5x minus 15, we can take out a positive 5. All right, and then we're left with an x minus 3. All right, still equals 0. And then the numbers out front becomes 2x plus 5, and then x minus 3 equals 0. All right, and now let's just set each of these equal to 0. All right, 2x plus 5 equals 0. All right, don't forget our zero product property. We want to set each of these equal to 0 and then solve for x. Right, so 2x plus 5 equals 0. We want to subtract 5 on both sides. All right, then we get 2x equals negative 5. And then we get x equals negative 5 over 2. All right, that's one of our solutions. And then our other solution, simply add 3 on both sides. All right, so then we should get x equals 3. All right. In our next case, right, number 6, our next example, right, first thing we want to check, are all of our terms on one side of the equation, right? No, they are not. We need to move this 3 to the other side, right? So we want to subtract 3 on both sides. Subtract 3, then 3 minus 3 becomes 0, right? And then on this side, 7 minus 3 becomes 4, positive 4, right? So then everything else stays the same. All right. I'll make sure I write a different color. Does that look better? Yeah, I think that looks better. Let me erase this. All right, 2x squared plus 9x plus 4 equals 0. All right, now Okay. Now we want to find factors of 2 times 4, right? So again, this is similar to the last one where our a term is not 1, right? So we want to do 2 times 4 gets you positive 8. So we want to find factors of 8 that add to 9, right? This should be super easy, right? It's going to be 8 and 1, right? 8 times 1, 8 plus 1. All right. Now, you can factor by grouping, right? There's another method that maybe I want to show you, right? I'm going to try to show you guys different ways to do these, right? Just in case maybe you're not a big fan of this grouping one, right? Hopefully you understand it, but maybe you want to try a different way to do it, right? So I'm going to show you how to solve it a different way. We can do it kind of in the way that I showed you not to do it, right, in this example. What we can do is make factors of x plus 8 and x plus 1, right? Just like I told you not to do, right? But if you like this way, then what you have to do to make it correct is to divide by our first term, right? Our first term is 2, right? So let's divide each of these. Let me use a different color. Right, let's divide each of these by 2, right? So divide this side by 2 and divide this side by 2. Whatever gets you a whole number stays, you can leave it alone, right? So x plus 8 divided by 2 gets you 4. So this side becomes 8 plus 4. But then this side, 1 over 2, right, that doesn't give you a whole number, right? It's a fraction. Right, so the bottom, you bring it up and you just throw it right in front of the x, right? 2x plus 1 equals 0, right? Now, I remember seeing this when I was tutoring a kid way back, right? He had showed it to me because I had only ever known the grouping method. But I think at his school they had learned it this way, right? I think they called it slide and divide. Right, slide and divide, right? So it's kind of catchy, right? So if you like it and it sticks, right, you can try it this way instead, right? But if you like just the factoring by grouping way, right, you'll get the exact same thing, right? So split up the middle term, you should get 2x squared plus 8x plus x plus 4 equals 0, right? Group the first 2, group the second 2. GCF of the first term is 2x, and then you're left with an x plus 4. GCF of the last 2 is 1. You're left with an x plus 4 equals 0, and then we get 2x plus 1 times x plus 4. Right, so look at that. That's the exact same thing, right? So in any case, let's actually solve this now, right? Just wanted to show you a different way how to do it. So let's get going, right? So x plus 4 equals 0, 2x plus 1 equals 0, right? Let's subtract 4 on both sides. We get x equals negative 4. All right, subtract 1 on both sides. We get 2x equals negative 1, and then we get, hang on. And then we get x equals, divide by 2 on both sides, x equals negative 1/2. All right, so 2 solutions. All right, good. Now let's keep going. All right, so let's try number 7 now. First thing we always want to check is everything on the same side of the equation. In this one, no, it's not, right? We want to get everything on one side of the equation. So let's move this 3x to the other side. All right, so let's subtract 3x. And then we should get 6x squared minus 3x equals 0. And then we want to take out a GCF. Let's take out a 3x. And then we're left with 2x minus 1 equals 0. And then we set each factor equal to 0. We get 3x equals 0. 2x minus 1 equals 0. All right, this first one, we just have to solve it by dividing by 3 on both sides. All right, so then we get x equals, whoa, that looks terrible. X equals 0. And then over here, we can add a 1 on both sides. All right, so then we get 2x equals 1. and then divide by 2 on both sides, we get x equals 1/2. All right, 2 solutions, right? We want 2 solutions, and we found them. All right, good. And the last one on this page, same as before, right? Let's get all the x terms on one side, setting the whole thing equal to 0, right? So subtract 2x on both sides, and then we get 8x squared minus 2x equals 2x minus 2x is 0. And now let's take out a GCF. All right, so let's take out a 2x. And so we're left with 4x minus 1 equals 0. And now zero product property. All right, we want to set each of these terms equal to 0. Each of these factors equal to 0, right? You might also hear zero factor property. All right, set each of these factors equal to 0 and then solve. Right, so then we get x equals 0. All right, we can add 1 on both sides. We get 4x equals 1. Divide by 4, divide by 4. And then we get x equals 1/4. All right, let's keep going with some examples. All right, when you look at something like number 9, all right, again, you want to get everything to one side of the equation, set the entire thing equal to 0. Right, is that done here? No, it is not. All right, so we want to move everything to one side of the equation. You could move the x squared to the other side, right? But then you'd have a negative x squared, right? I like the x squared how it is, right? So let's move the other two, right? Let's move the 6x to the other side, and let's move the 9 to the other side, right? So plus 6x plus 9, right? Cancel, 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 cancel. Then we get x squared plus 6x plus 9 equals 0. All right, now that it's set equal to 0, we can factor this and then set each factor equal to 0, right? So what multiplies to 9 and adds to 6 is going to be 3 and 3. All right, so this is actually a perfect square trinomial. All right, so you could have noticed that you can take the square root of the first term, square root of the second term, right? Oh, not there. Right, square root of the first term, square root of the second term. All right, then you get an x times 3. Let me use a different color. X times 3, and then double it. Then you get 6x. Is that the middle term? Yes, it is. The sign is positive. All right, so we get the same thing squared, right? X times 3, or no, x plus 3 times x plus 3. All right, so this is a perfect square trinomial, right? You can test it, right? It's going to work. All right, and now we want to set each of these equal to 0, right? So x plus 3 equals 0, and then x plus 3 equals 0. All right, and then subtract 3, subtract 3, subtract 3, subtract 3. Notice that we get x equals negative 3, and also x equals negative 3. Now I know I stressed that in these kinds of problems we need 2 solutions, right? Here we got 2 solutions, they just happen to be the same, right? If this happens, you are allowed to just write it once, right? You don't have to write it both times, right? X equals negative 3 and x equals negative 3. If they're the exact same thing, you can just write it once, right? I don't need to see it twice. As long as I see the work that you did, everything that you needed to do to get to this answer, right? You don't need to write it twice. X equals negative 3 is enough. All right? Now let's try something like this one, right? 4x squared plus 12x plus 9, right? Now we can do our AC method as before, right? So multiply the first term times the last term, right? Everything is already set equal to 0, right? That part is done, right? So now we just want to factor and solve, right? So 4 times 9 gets you 36, right? So what multiplies to get you 36, and what adds to get you 12, right? And what adds to get you your middle term. All right, this is going to be 6 and 6, all right? So you could split it up, factor by grouping, right? I showed you guys a different way how to do it earlier in this video, so let me try it that way also, right? If you remember, once we get these two numbers, you can do x plus 6 times x plus 6, right? But you can't leave it like that, right? I told you guys not to do that, but that's because you cannot leave this by itself as your answer, right? If you do it this way, you need to divide by the first term, right? So divide each of these 6's by 4, right? And then this didn't happen in the other problem, but here we can simplify this, right? So it becomes x plus 6 over 4 simplifies to 3 over 2. All right, then we get x times 3 over 2, x plus 3 over 2. All right, 6 over 4, we get the same thing here, 2 times. All right, so all we have to do, now you could from this part just set it equal to 0, right, each of these factors, because then all you have to do is subtract 3 over 2 on both sides. Right, so this factor equals 0 and this factor equals 0. Right, x plus 3 over 2 equals 0, x plus 3 over 2 equals 0. All right, then we get x equals negative 3 over 2, and then x equals negative 3 over 2 again. Right, but again, once you get your solution and you see that it's the same thing twice, right, as long as you show all your work to get to this step, you can just write it once, right? You don't have to write it twice. All right, and then I think I didn't finish factoring this, right? I kind of left you guys on a cliffhanger there, right? But this right here, and I'll do it off to the side, right? This is going to factor. You take the bottom and you move it out front, right? Once you simplify your fraction, you move it out front, right? So if you want to write this in its fully factored expression, right, this is going to become 2x plus 3 times 2x plus 3, right? So this right here is the same as this, right? I just didn't write it that way because the goal here is to solve for x, right? So if we were to solve for x, we would have had to undo that step anyway, right? So I just wanted to skip it entirely, right? But this is going to be your factored expression, and this, and you can even verify, is going to be equivalent to this, all right? Now, if you wanted to do it the other way, factoring by grouping, right, once you get your 6 and your 6, right, and I'll do that up here, you can verify that it's the same thing, right? You get 4x squared plus 6x plus 6x plus 9 equals 0. All right, group the first two, group the second two. GCF of the first two is going to be a 2x, right? You're left with a 2x plus 3. And then GCF of your second two is going to be a 3. And then you're left with a 2x plus 3 equals 0. And then 2x plus 3 become its own group. All right, and then you still have that 2x plus 3 from before. And then you say each of these equal to 0, right? 2x plus 3 equals 0. And then 2x plus 3 equals 0. And then you can verify that you get the exact same solutions. All right, so x equals negative 3 over 2. All right, and now let's try one more. All right, let's try number 11. This one should be a little bit easier than the other two, right? This is the easy case where a equals 1, right? We have nothing in front of the x squared, right? So we're just looking for factors of negative 8 that add to negative 2, right? So factors of negative 8 that add to negative 2 are going to be negative 4 and positive 2. All right, negative 4 times 2 gets you negative 8, and when you add them, you get negative 2. Right, now that it's fully factored, right, zero product property, let each of these equal 0, right? So x minus 4 equals 0, x plus 2 equals 0, right? Add 4, so we get x equals 4, subtract 2, then we get x equals negative 2. All right, let's keep going. So number 12, we have negative x squared plus 4x equals 3. Right, so again, the first thing you always want to do is get everything to one side of the equation. Now, I don't like the x squared being negative, right? So typically I move things from the right to the left. This time I'll move things from the left to the right, right? I don't like that x squared being negative. So we can add x squared on both sides, and we can subtract 4x, right? Just because, and you're going to see why. I don't like the x squared being negative, right? So then everything on the left cancels out and becomes 0. And then this equals, I'm going to write it in standard form so that you guys can see that this is easy to factor, right? We get x squared minus 4x, and then finally that plus 3, right? Now this is pretty simple to factor, right? We're just looking for factors of positive 3 that add to negative 4. All right, so then we're just left with x minus 3, right, x minus 1. All right, and then now we can do our zero product property and let each of these equal 0, right? X minus 3 equals 0, x minus 1 equals 0. All right, so we want to add 3, add 1, add 1. So then we get x equals 3, and then x equals 1. All right, simple as that. All right. And then number 13, right? Don't let the fraction scare you, right? We just had a whole test on mostly fractions, right? So you should know how to get rid of this denominator, right? If there's an 8 on the bottom, what do you need to multiply this equation by to get rid of that 8, right? It's going to be an 8, right? 8 over 8 goes away, right? So then distribute 8 to everything, even the 0, right? Even though 8 times 0 is 0, right? Distribute it to everything, right? So then we get 8 over 8 x squared minus 8x squared, or no, minus 8x, and then minus 16 times 8 should get you 128, right? Equals 0 times 8 is 0. All right, so something like 8 times 16, maybe you need to do up to the side. That's fine, right? If you can't do it in your head, right? There's nothing wrong with just writing it off to the side, taking a little break from it, all right? You want to be accurate, right? If you can't do it in your head, don't do it in your head, right? Do it off to the side. And then 8 divided by 8 goes away, right? That becomes 1, so then we're just left with x squared minus 8x minus 128 equals 0. Now we want to look for factors of negative 128 that add to negative 8. Right, you want to be a little bit smarter with these, right? You don't want to go through all of the factors of negative 128 and then say like, okay, 2 and 64, for example, right? Those aren't going to get you anywhere near negative 8, right? You can also tell we literally just multiplied an 8 and a negative 16 to get that negative 128. So now you know that 8 and negative 16 are factors of negative 128. Do they add to negative 8? Yes, they do, right? So you want to group, right? Do x plus 8, x minus 16 equals 0. And now we just solve as normal, right? Zero product property, x plus 8 equals 0, x minus 16 equals 0, right? So then x should equal negative 8, and then x equals 16. All right, now let's get into the second part of this lesson. Right, we're gonna solve equations by taking the square roots. Now, this is a special case where you see a 2 in the exponent, right? So you see an x squared term, right? But you don't see an x with it, right? So in all of these, we've been able to factor, by grouping, just doing what multiplies to the last term, adds to the middle, things like that. But in all of those cases, we saw that x squared with an x somewhere in the equation, right? But in this case, we don't see an x squared at all. Or no, we don't see an x at all. We just see an x squared, right? So when this happens, if you have x squared equals something, right, all you have to do to undo a square, right, what's the opposite of squaring something? Right, it's going to be square rooting something, right? So take the square root. We can take the square root on both sides, right? Just like we can add the same thing on both sides, subtract the same thing on both sides, multiply, divide the same thing on both sides. We can take the square root of both sides of an equation, and it won't change our solution, right? We'll get a true statement, right? So square root cancels with the square, so we get x equals. Is it just going to be the square root? No, right? We need to add a plus or minus in front of it. So plus or minus the square root of something. And just because, right, let's say you square 2, for example, right? 2 squared is what? 4, obviously, right? 2 times 2, right? But let's say you square a negative 2. What is this? Right, negative 2 times negative 2 is going to get you positive 4. we just got two answers that when we squared them, we got the exact same number, right? So we need to account for that case by putting a plus or minus in front of it, right? And then we'll do some examples now. Okay, let's get started. We can start with number 14. This is one of our cases where we just see an x squared. We don't see an x anywhere in this equation, right? And if you try to do it the other way, right, and just getting everything equal to 0, right, when you move the 15 to the other side, let's say you get x squared minus 15 equals 0, right? What can you really do with that? Nothing really, right? I think maybe some of you are going to try to do a difference of squares and do like some crazy things right here, right? But no, there's no need for that, right? You can't do that here, right? You're not going to get perfect square at least, right? So we want to leave this alone, right? So let's leave it, whoa, okay. Okay, so let's leave this alone and let's isolate the x squared. And right now it's already isolated. And now we just want to undo the square root, or we just want to undo the square, right, by square rooting, right? The opposite of squaring something is square rooting something, right? To undo a square, take the square root. And what we do to one side, we have to do to the other, right? So take the square root of x squared, we get x equals, and then we get square root of 15. But we can't leave it alone like this. Remember, we need to include the plus or minus 15. Right, this just means we get two solutions, right? X equals positive square root of 15 and x equals negative square root of 15, right? So we get two solutions here, right? 1 and 2. But we can account for both of them just by writing it like this, right? So you can write it twice if you want, but plus or minus is enough, right? This is perfectly understandable, right? And now, this just basically means if we plug in square root of 15 into x, we're going to get 15. When we plug in negative square root of 15 into x, we're going to get 15, right? Because both of these values, when you square them, are going to get you 15. They are both a solution to this equation. All right. Now let's try the same thing with number 15. All right. So same thing here. The x squared is by itself. Right, so all you have to do in this case, take the square root on both sides, just like the last one. Opposite of a square root, or opposite of a square is square root, right? So we can cancel out the squares. We get x equals plus or minus square root of 48. All right, you can't just leave it as 48. Right, very common mistake that a lot of people make when doing this for the first time, right? And even if you're well into this, you maybe forget it at some point. Right, so don't forget the plus or minus. And now we have to check if 48 can be simplified anymore, square root of 48, right? I didn't do it for the last problem, even though I should have, right? So if you look at square root of 15, can that simplify at all? Is 15 a perfect square, or does 15 have factors that are perfect squares? No, right? So we leave it alone. But when you look at 48 does have factors that are perfect squares, right? The most apparent one to me, or the easiest one to, or the one that'll make this problem the easiest, is 16 and 3. Right, 16, square root of 16, square root of 3, right? Plus or minus. All right, and then square root of 16 is 4. So x equals plus or minus 4 square root of 3. And then this would be our answer, right? Now that it's fully simplified, because 3 is not a perfect square, nor does it simplify into any perfect squares, into any factors of perfect squares, I mean, right? And now this goes back to our simplifying radicals section, right? So you should refresh on that if you were a little shaky on that. You didn't have to do 16 and 3 if you didn't recognize it at first, right? So maybe if you got square root of 48, maybe some more obvious factors, maybe you get 6 and 8, or 4 and 12, right? So let's say square root of 4, square root of 12, right? Square root of 4 is a perfect square, that gets you 2. But then you have to think, does 12 have any factors that are perfect squares? And yes, it does, right? We want to break it down into square root of 4, square root of 3. And then square root of 4 is 2. So then you get 2 times 2 square root of 3, right? So we get 2 times 2 is 4 times the square root of 3, and then we get the exact same answer, right? Plus or minus. All right, good. And now let's try something like number 16. Now, something like number 16 looks a little bit different, right? Now, one way to do it is you could quite literally write it out twice, right? FOIL, and then subtract 20 on both sides, right? Minus 20, minus 20. But you don't want to do that, right? That's going to be way too much work. You could just see that this entire side of the equation is squared, right? So we can undo that square in one step right now, right? All you have to do to undo that square, again, just take the square root on both sides, right? Once you take the square root, this square root cancels with the square. We get 4x plus 1 equals, and then square root of 20, we have to add a plus or minus, right? So plus or minus 20. All right. And now you can check from here if 20 simplifies, right? And it does, right? 20 has factors of 4 and 5, right? And then square root of 4 becomes 2 times the square root of 5, right? Plus or minus, right? So then 4x plus 1 equals plus or minus 2 square root of 5. And now we're not done, even though maybe that seemed like a lot of work, but we're not done, right? We have to solve for x fully, right? So let's subtract 1 on both sides, cancel it out. Then we get 4x equals negative 1 plus or minus the square root of, or 2 square root of 5. All right, and then the last thing you want to do is divide both sides by 4. All right, so then we get x equals negative 1 plus or minus 2 square root of 5 over 4. All right, and then that would be your final answer. Notice that if we tried to FOIL everything out, bring the 20 to the other side, you know, like I wrote up here, right, that would have given you a very tricky case. Right now, there is a way to solve it by doing that, but we're not going to learn that for another little bit. That'll be later in the section, right, when we use the quadratic formula. Right, maybe you've seen it in Algebra 1, but we're not going to do that yet, right? That's going to be a little bit later. All right, but again, we get two solutions here, right? One positive, one negative, 2 square root of 5. All right, so that's where our two solutions come from. Again, you want to make sure that every time you see a 2 over the variable that you get two solutions, right? And in this case, we do. The plus or minus accounts for that. All right, and then you can just leave it alone like this, all right? It's not the prettiest looking thing, but it's what we got, so it is what it is. All right, so now let's try number 17. All right, last one on this page. All right, immediately let's add 43 on both sides because we want the x squared by itself, right? In this case, when we don't see an x with the x squared, we want to get the x squared by itself and then solve by square rooting. All right, so then doing this gets us x squared equals 0 plus 43, we get 43. And then we take the square root on both sides. Square root cancels with the square root. And then we get x equals plus or minus the square root of 43. All right, and then 43 does not have any factors that are perfect squares, right? And 43 itself is not a perfect square, so you can leave your answer alone like this. All right, again, so the way this was written, right? You don't want to do a difference of squares, right? I have a feeling maybe some of you are going to try to do something like that here, right? There's no need for that. You're not going to be able to do that, right? Get the 43 to the other side and then take the square root, right? That's the easiest way to solve this. All right, let's keep going. Something like number 18, right? Following along the theme of taking the square root, right? We want to get the x squared by itself. To get the x squared by itself, we want to divide by this 9 out front, right? Divide by 9, divide by 9. And then once we do that, this 9 goes away, then we get x squared equals 36 divided by 9 is 4. Now that we have the x squared by itself, we just have to take the square root of both sides. We get x equals plus or minus square root of 4 is 2. All right, and then we get our two answers, right? Positive 2 and negative 2. Again, the plus or minus just means you get two answers. One is positive, one is negative. Now, I just wanted to highlight something. There's another way to do this, right? If you were comfortable before, right, earlier in this video, maybe you wanted to bring this 36 to the other side, and then we get 9x squared minus 36 equals 0, right? This actually can be factored, right? 9x squared and 36 are both perfect squares. Since they're both perfect squares, you can factor them as a difference of squares, right? 9x squared square root of that is going to be 3x, and then square root of 36 is 6. So we get 3x plus 6, 3x minus 6, and then we do our zero products property, right? Now, it might not look like it's going to get to 2 and negative 2, right? But just watch, right? We get 3x plus 6 equals 0, 3x minus 6 equals 0. All right, subtract 6 on both sides. We get 3x equals negative 6, divide by 3, divide by 3. We get x equals negative 2, and then here we can add 6 on both sides. Same exact process. And we get x equals 2, and we get x equals negative 2. Now we still get our two solutions, right? Negative 2 and 2. All right, but notice that just by taking the square root of both sides, it made it a little bit shorter, right? I feel like I would much rather do something like this than to do all of this work, right? Even though it works just as well, right? You get the exact same answer, right? But if you can recognize that you're able to take a square root, and remember, you can only take a square root of an x squared if you only see an x squared, right? You can't see like, okay, x squared if it was like plus, I don't know, 12x or something like that, right? You couldn't do that because you still have this extra x term that you have to worry about, right? You can only do that when there's the x squared by itself, right? You just get the x squared by itself and then take the square root, adding a plus or minus out front. All right, good. Now let's try something like number 19. All right, now 25x squared equals 37. Just like before, we want to get the x squared by itself. All right, so let's divide both sides by 25. Then we get x squared equals 37 over 25. All right, and then you want to square root, right? So then we get x equals plus or minus square root of 37 over 25. All right, can we leave our answer like that? Absolutely not, right? We need to simplify this a bit more, right? Remember, and I remember way back on that first, I think, test or quiz, right? This stumped a lot of you, right? To simplify something like square root of 37 over 25, you need to split up the fraction, right? So this is the same as plus or minus square root of 37 over square root of 25, right? And then between these two, we just want to simplify both of these. We don't want a square root in the denominator, right? So what we want to do, look at the denominator. Can it simplify? And this one can, right? This one just becomes 5, right? Square root of 25 is 5. And then we get square root of 37 on the top. Can square root of 37 simplify? No, it can't, right? So we just get our two solutions here, right? X equals plus or minus square root of 37 over 5. So whenever you see a square root in the denominator, you need to simplify it, right? So we didn't go over that section for nothing, right? We want to simplify, right? And this one, it worked out to be a whole number, so perfect, right? But in any case, you want to make sure that there's no radical in the denominator. All right. Now let's try number 20. All right, number 20 looks a little different, right? We don't just have an x squared. We have an x minus 5 squared, right? Now, I'll tell you guys this. As long as you have a squared term by itself, right? So if it was just x squared, you knew that you just had to take the square root of both sides. But we can still just take the square root of both sides, just like we've been doing before, because this square on top is going to cancel with the square root. And we're just left with x minus 5 equals plus or minus the square root of 25. All right. And now you can simplify this right away if you want, right? So we get x minus 5 equals plus or minus square root of 25 is 5. All right, but we're not done, right? We still need to get this 5 to the other side, right? So we want to add 5. Now I don't really like how that looks, right? So does that look better? Yeah, I think that's fine. Okay, so we can add 5. So then we get x equals 5 plus or minus 5. Now, in all of our other cases, we were able to just leave it. So if you remember on the last slide, we were able to just leave, like, okay, we had like a big expression with a radical, right? We were able to just leave it alone and say, okay, boom, there's your answer. But in this case, we can actually separate them and get whole numbers as your answer, right? Because 5 plus or minus 5, we actually can split up our two solutions, right? So then we get x equals 5 plus 5, and then x equals 5 minus 5, right? Can these simplify? Of course they can, right? We get 5 plus 5 is 10, 5 minus 5 is 0, right? So we get our two solutions right here. Nice whole numbers, right? So one way to even verify it, right? Foil everything, right? Maybe you could have, if you wanted to check if you liked the way that we were doing it earlier in this video, right? What you could have done is done x minus 5 times x minus 5, right? Foil that, and then move the 25 over to the other side. Set the whole thing equal to 0, factor, and then use zero product property to get each of the factors equal to 0. You're going to do that and you'll get the exact same answers, right? But if it's already set up for us in this way, right, there's no need to do all that extra work, right? All you have to do is just take the square root to get rid of the square on the outside, right? It's set up like this for a reason. All right. Okay, good. And now let's try the same thing with number 21, right? So like I said before, right, if you have the squared term, or if you have the squared over terms in parentheses, right, and that's the only thing that you have on that side of the equation, then you can get rid of this entire square right away by taking the square root. All right, so square root. This square root is going to cancel with the square, and then we're left with x plus 9 equals plus or minus the square root of 24. All right. Now, does this simplify at all? Yeah, right? We want to simplify square root of 24, right? What goes into 24? That's a perfect square, right? We have 4 and 6, right? And then square root of 4 is 2. Square root of 6 can't simplify, so we have x plus 9 equals plus or minus. I'm going to write 2 square root of 6. All right, I like to write the whole number out front. And then the other thing that we can do to finish this problem is to subtract the 9 on both sides, right? 9 minus 9 goes away, so then we get x equals negative 9 plus or minus 2 square root of 6, all right? And now these can't combine at all, right? If you remember from our simplifying radical section, you can't combine a whole number with a radical, right? So we leave this alone as is. We can't simplify it any further like we could the last problem. Now, another thing I wanted to mention, if you wanted, you could have written it as plus or minus 2 square root of 6 minus 9. I prefer to leave the square root at the end, right? Just because depending on how you write it, right, you maybe get confused by your own handwriting. I think you know yourself well enough to know if you would do something like that. But if you're doing it for the first time, it's really easy to let this negative 9 sneak into that square root like that at the end of that, right? And you don't want that to happen. All right, so that's why I like to write the plus or minus after, right? Because the plus or minus is the one that typically has the square root with it, right? And you'll see that as a common pattern here, right? But yeah, either way it's fine, right? It's just this, writing it this way is much easier to read. All right, so we have two more examples, right? So something like 22 is something that we've done before, right? In the last slide, the last two examples are very similar to this one, right? As long as we have the square term by itself, right? So this entire thing is the one that's being squared, and we have nothing else around it, then we can take the square root of both sides, right? So the square root cancels with the square, so we're left with 4x plus 7 equals plus or minus square root of 44, right? Again, guys, don't forget the plus or minus ever. And then we can simplify square root of 44, right? What does this become? Does it have any factors that are perfect squares? Yes, it does, right? Square root of 4, square root of 11. And then square root of 4 is a perfect square. We get 2 square root of 11, and then square root of 11 can't simplify. All right, so then we get 4x plus 7 equals plus or minus 2 square root of 11. All right, and then we just solve as normal, right? Subtract 7 on both sides. Then we get 4x equals negative 7 plus or minus 2 square root of 11. And then the last thing we want to do is divide both sides by 4. All right, cancel out the 4's. We get x equals negative 7 plus or minus 2 square root of 11 over 4. Right? It's not the prettiest answer, I know, right? But it is what it is. This is the answer that we got. We did all the steps correctly, right? Everything looks fully simplified, so we're good to go, right? If you get an answer this terrible looking, right, don't be afraid. We might not like it, but it is what it is, right? We get an answer. All right, good. And then this last one is a little bit of a trickier one, right? A little bit of a more difficult one also. Right, now you maybe think, okay, we can take the square root of both sides, right? Just like we did the last one. And you might be thinking, ooh, well, there's two of them this time, right? But maybe you think, okay, well, if it worked before, it should work for this one, right? If we take the square root, and I'll do it up here, if we take the square root of both sides, we get x plus 5 equals x plus 4, right? Now, which one has the plus or minus, right? Shouldn't really matter, right? Let's just say we left it like this, right? And then we want to get the x to one side, but look at what happens here. We get 5 equals 4. Is this true? It's not, right? And you might be tempted to think, okay, you did this, and it's a false statement, so it's no solution. That's not true. This one will have a solution, right? You actually have to work it out this time, right? So this one's going to give you, okay, let me go ahead and erase this, and I'll show you how I would do it, right? So there's a couple ways to do it. You can FOIL everything and get everything to one side, right? Do it the same way that we've been doing it earlier in this lesson. But if you do that, you might see that the x squareds cancel out, and then you just have a linear equation, right? That should be, once everything is FOILed out completely, then it should be pretty simple. But the way that I would do it is to bring everything to one side and then factor, right? To bring everything to one side and set it equal to 0, right? Let's subtract x plus 4 squared on both sides, right? I'm about to do something a little bit clever here, but if you don't like it, I'll show you how it's going to work out if you want to FOIL it. So then we're left with something like this. X plus 5 squared minus x plus 4 squared equals 0, right? This side, everything goes away. All right? Now what happens here? Right? It might not be super obvious, but hopefully you should catch it, right? We see two terms that are being squared, right? And they're being subtracted. Okay. Hopefully at this point you're like, oh, difference of squares, right? This is a difference of squares. It's not the prettiest difference of squares, but it's a difference of squares nonetheless, right? So we can factor it as follows, right? So it becomes, right? I'm actually gonna make it. I'm actually gonna make my two groups into big parentheses. All right, so I have a big parenthesis here, all right, equals 0. And then in my first one, it's going to be square root of the first, which is going to be x plus 5, plus square root of the second, so plus x plus 4. And then in my second group, it's going to be square root of the first, x plus 5, minus square root of the second, x plus 4. All right, equals 0. Right, and this is a difference of squares, guys. Right, and now when we simplify our difference of squares, what do we get in each set of parentheses? Right, remember your order of operations, guys. You don't want to go crazy with the parentheses. That's why I made them this comically large parentheses, right? Just so that you can clearly see we're working on the inside of here first and the inside of here also, right? And then we're going from there, right? X plus 5 plus x plus 4. All right, so we have an x plus an x. We can combine like terms, right? We get 2x, and then 5 plus 4 gets you 9, right? So 2x plus 9. And then on this side, this minus is going to distribute to each term, so we get x plus 5 minus x minus 4. Remember, the negative or the minus between them, you can treat it like a -1, and then change the sign of everything on the inside. All right, and then x minus x, that goes away, right? That just becomes 0. And then we get 5 minus 4 is 1. All right, and then this equation, or let me write it like this. All right, so let me shrink it down a bit, right? I know I drew it kind of big, but let's shrink it down a bit. We get 2x plus 9 times 1 equals 0, right? Remember, we set it equal to 0. And now anything times 1 is itself. All right, you agree? All right, so we get 2x plus 9 equals 0. And this is a case, we actually just get one solution, right? Everything up until now, we've had two solutions. But that's because the squared terms are going to cancel out, right? And I'll show you again, right? By foiling everything that it's going to work out the same way. And then we just want to subtract 9 on both sides. So we get 2x equals -9. Divide both sides by 2, we get x equals -9/2. All right, so we get one solution here, right? This is a special case where the x squareds cancel out. All right, and then I'll show you up here, right? It's going to FOIL as follows, right? If you wanted to do it this way, x plus 5 squared is the same as x plus 5 times x plus 5, right? FOILing it, we should get x squared, and then we get 5x plus 5x, which is 10x, and then plus 25. And then the other one is going to be, okay, x plus 4 times x plus 4. Foiling that, we get x squared, right? 4x plus 4x is 8x, and then plus 16, right? So then we have this is equal to this, right? These are equal. And now to get everything to one side, let's subtract the x squared, but just doing that right away, you're going to see the x squared terms cancel out. So we get 10x plus 25 equals 8x plus 16. And then now let's solve it, right? Let's get the x's to one side, so we move 8x to the other side. We get 2x, subtract 25 on both sides, equals -9. And then just divide by 2 on both sides, we should get the same thing, x equals -9/2. Right, so again, just one solution because the x squareds cancel out. But if that x squared was there and didn't cancel out, we should get two solutions, right? But this is a case where we just get one. All right, and then that's the entire lesson, right? That was a little bit of a trickier one, but hopefully after seeing it, you understand it a little bit better. All right.